Today I will be discussing problems for Codeforces Round 798. So I participated in a competitive contest after a really long time. So my submission timing for each problem was not up to the mark, but still I was able to get 3 out of 5 problems. Let's go over each of them one by one. So the first problem is problem A, and in this problem I won't go over all the description that is provided. I will directly jump to my whiteboard and I will do the explanation here. So we are given two strings. One string is A, right, and it consists of some lowercase characters like A, B, C. And similarly, we are provided with a string B, and it also consists of lowercase characters, and those characters will be distinct from the ones that are present in string A. So let's say if string A has A, B, C as lowercase characters, B might have D, E, F, H, but it won't have ABC as the question describes. Now, what we need to do here is we need to create a new string C, and string C is initially empty, so it has nothing. Now we can form string C by doing two operations. So the first operation could be you choose any character from A, remove it from A, and then add it to the end of C, or you can choose any character from B and then add it to the end of C. Now what you can do here is there is a condition, a constraint. So you cannot do more than k operations of the same type. What does it mean? So by same type it means that, let's say in the first operation I added a character from A to C. So if my k value was 1, so I cannot do the same operation again, in the sense that in the next iteration I cannot take a character from A. I will have to take a character from B, and that's why this constraint k is there. Now, after considering all the constraints, we need to create a string C, and the string C should be lexicographically smallest. So what does it mean? In the sense that here is a definition. I won't go over it in detail, but by lexicographically smallest, it means, let's say I have a string A, B, C, D, and if I have a string A, B, C. So here this string is going to be lexicographically smaller than the above string. Why? Because if at first character they match, but at the second character they don't match, but this one has a more smaller ASCII value, right? So this is considered my answer. Now what was my approach here? Let me remove all of these things. So my approach here was, if I have given, let's take a sample input. If I have given a string 1 2 3 4 5 6 A, okay, so if I have a string A consisting of all A, and I have a string consisting of 4 B's, right, and the k value is 2, so k value is 2, and we can do the operation like we can take one character from A and one character from B, add it to the C. We can only do it when till the time either of them becomes empty, right? And that could happen at any time. Let's see with this example. So what I can do here is, what I did, because I can pick any character, I added both the strings, like both the strings to a vector. I then did a sort on it. Currently in this case the sorting will give us the same output. Now after doing the sorting of each string, I started with the first index, because now it's sorted, so it means that the values of my lowercase letters will be in ascending order. So I will start with the 0 index. I will pick, because A is smaller, so when I am forming C, my first character will be A. Now I move the iterator to for the A to this point, which is the second A, and my pointer for B string stays there because I haven't removed any character from B yet. So I can again pick A because A is smaller than B, and I need to form lexicographically smaller string. So then I move my iterator in A till the next point, so which is the position 2. I can again pick no, I cannot pick A at this time. Why? Because of the value K, because in previous two operations I picked a character from A. So this constraint is met, so I'm forced to pick one character from B. So I will pick B here, and this will be my string. Now my pointer for B moves here. Now my operation, this K has become 0 for A, right? So I can again pick A, pointer moves here. I can again pick A, pointer moves here, but at this time again my constraint is met, that is K is equal to 2. So I'll have to pick one from B. I pick a B, then I can pick A again, but at this time my A has become empty, so I will exit out and I will print the output, and you can see this is the output for our case. I'll increase the zoom. Okay, this is the output. So this is how I solved the first problem. Let's go to the next problem, mystic permutation. So let me remove all of these. So the B problem states that you are given a value n, right, and after n you are given some numbers. So the numbers will consist of values between 1 to n. It is short. It says that it will have n distinct positive integers, p1 to pn, and the values are between 1 to n. So for example, if n is 5, I am guaranteed that my array will have 1 2 3 4 5, but the order could be anything, like maybe the input says 2 3 4 1 5, something like that, right? So what we need to do here is we need to form another permutation, which is a part of old permutation. Now permutation means that I will need to use all these numbers only and form a new group of numbers, like a new array. Now the condition here is that it should again be lexicographically uh, smaller. Like for example, let me remove all of this. So in our case, let's say n is 5, and I am given an array like this 3 2 4 1 5. So if I need to form a permutation of this array, and if I need it to be lexicographically smaller than this permutation, what will I do here is I will first pick 1 2 3 and then 5 and then 4. This will be my answer, and you can see that this is going to be smaller than the above one, and you cannot make anything that is smaller than this one, right? The reason I picked 5 here and 4 here is because if I had picked 4 here, I need to place 5 here, and the condition states that in the new permutation you cannot have same values at the same index. So if my 5 comes at this index, then it will be similar to my previous permutation, and that's not right. So the way I solved this one was in a very greedy format. So what I did here, let's say let's take a sample input. So I have 2 3 4 5 1. Yeah, let's go with this one, 2 3 4 5 1. So my input is 2 3 4 5 1. The reason I did greedy here is I know that if 2 is at first place, I can place 1 because that is smaller. Now when I see 3, obviously I can use 2. Now I move here, I have 4, I can use 3. Now I have 5 here, I can use 4, and then I can use 5. So this will be my answer. So what I did, I basically, when I get the input, I move it to a heap. So I move it to a min heap, and in the min heap it automatically sorts in the ascending order. So it keeps 1 2 3 4 5, right? And what I do here is I for each index I, like when my index is I, if my min heap top is not equal to my value, that is p1, so then I just add it to the new answer array. Similarly, I move the pointer to the next point, right, which is 3. Now I pop out of min heap. Now my top of min heap is 2, and I see the value at my existing permutation is 3, so I know they are not equal, so I will print 2 here, and that's how I go ahead with that, and I get my answer. So using min heap did help me a lot. Don't worry, I will be sharing the code links to the submissions that I made in the description of the video, so you guys can go ahead and take a look at it later. But right now I just want to explain the concept, the approach. Okay, let's move on to the third one. The third one was a little tricky, but it's an interesting problem. So I hope you guys have already read the question, but so I will go ahead with the explanation. So what we are given, the question states few things. It's a binary tree. What's the definition of binary tree? So by the name, it suggests that if I have a node 1, at max I can have only 2 children. So I can have only 2 children, that's it. I cannot have a third child, because then it won't be a binary tree. So this gives us a little bit ease at solving the problem, and we'll see how that is possible. Now what the question states here is, we are given n vertices and there are n minus 1 edges, and unfortunately the vertex 1, which is considered to be the root, it says that root is the vertex with the number 1 and it has a degree at most 2, right? And now this statement, yeah, let me explain this statement. Each vertex has a degree at most 3. The reason is, let's say I have a tree like this. So by degree it means how many edges it has. So this node 2, this basically has 3 edges, right? So the degree is 3. That's the only thing it states, so don't get confused with that. Now the following things happen in the process. So what happens is, our root node is 1, which is already infected. Now Misha basically gets a chance to save some nodes, so the infection is spreading from root to its children at each iteration, right? So Misha can save some nodes by cutting down the edges. And what it says is, let's say I have this tree 1 2 3 4 5 6 7. So let's go step by step. Now we know that node 1 is already infected, so let me mark it with red. So this is infected. Now I have two options here. In the next turn, I know the infection will either spread it to 2 or it will spread to 3. So what I can do here is, I can either cut down this one, or I can cut down this one. I have to choose one of them. So whenever I cut down anything, so let's say I remove this. So let's say I cut down 3. So what will happen when I cut down 3? The 3 node is gone. I cannot save it because I have cut down that edge of that node. So think like I killed that node. But in the process, I save these 2 nodes that I'm marking it as green. So I save two nodes here, and the 2 gets infected in the next turn. So 2 will get infected. Now what I can do in the next turn is, I can either cut down 4 or I can cut down 5. But even though I cut down 4, let's say I cut down 4, right? Because I cut down that node, it's already dead, so I cannot save it. And in the next turn, 5 will get infected. So overall, I can only save 2 nodes, which is 6 and 7, or I can save 4 and 5. And this is what we need to find, that what steps you can take at each iteration, like what nodes can I cut, like what edges can I cut, so that the number of nodes saved is maximized. And that's what our output of this problem will be. So the way I solved this question was, let me get rid of all of these and create a new tree. So what I did here is, let's say 3, 4, 5, 6, 7, 8, 9. Okay, something like this. So I have a tree like this. What I did here is I first calculated the number of children that are under a root. So let's say 8 and 7 are leaf nodes. So the children under node 6 are have count 2. Let me mark it with something else. I can use a different color. So I can use purple. So it has 2 nodes, 2 children nodes. Similarly, 9 is a leaf node, but node 2 will have how many children? It will add 6 to it also, because I'll return 6. At the same time, I'll return 9. So it is having 1, 2, 3, 4 nodes. Similarly, 3 is having 2 nodes, 9 is having 0, 0, 0, 0, 0, and this will be 4 plus 2. So 4 plus 2 plus 2, which will be 8. 1, 2, 3, 4, 5, 6, 7. Okay, so node 1 will have 8 children. So once I calculate this part, now the way I want to maximize the number of nodes or number of children that I can save, is by cutting down the child node which has less number of children, right? So in our case, our solution is pretty easy. In this case, I can easily cut down this node 2 so that I can save 4 nodes here, and then I can let go of this node. Like I can let it infect in the next turn, because I won't be able to solve, because if I cut down this one, then I can only save 2 nodes and I might lose some nodes here, right? So my solution here will be 4. So 4 is my answer in this case. That is how I'm maximizing. And what I do, once I have calculated a number of children in one traversal, I do another traversal, and in that traversal, at each step, I am trying to calculate maximum number of children saved bottom up. So I basically go down from 8 and 7, and then I'm going up towards it, and that's how I calculate. Obviously I'll have to use DP also here, like I'm keeping track of a DP of for each node, so that I don't reiterate or again traverse that node if I've already traversed, and because it can cause a time limit exceed kind of error. And that's how I was able to solve these 3 questions. Hope you guys like this video. As I said, I'll be adding solutions to the description of the video, and please subscribe to my channel, give me a thumbs up, like on this video, follow me on Instagram, and thanks for the support.